Hey, and welcome to this mind-boggling video on delegates, and hopefully it's going to be really informative for you. Don't expect yourself to fully absorb this time if it's the first time you've seen delegates. Just go through it and let yourself absorb delegates as we go through the course, or go and get yourself some real-time help in the discussions and in the chat. But by the end of the video, what we will have is a situation where instead of this cursor being set every single frame, if you look, it's still changing, but look down on the console, it only changes when the layer changes. So there's been one change there and one more change as I go back over the ground. So we're not frantically changing the cursor, we only change it when we need to. Okay, and we'll set up a beautiful architecture where any other component we want can actually register itself as a listener for the fact the layer that the cursor is over has changed. So for example, I might want to hover over this dude and have his name pop up at the top of the screen. Well, now we can do that without changing the camera raycaster at all. We can just register as an observer of the camera raycaster, of an observer of the fact that it's saying a layer's changed, and then you could pop his name up in the UI. So it's a really cool observer pattern implementation using delegates in C# in Unity, and I look forward to getting in there and showing you how it's done. So in the first part of this video, we need to declare a new delegate subject type. So remember this diagram I showed you a couple of videos ago? We were saying that we were going to have the camera raycaster call a method called onLayerChange in cursor affordance and send some data along with it. Well, I'm going to simplify that for now. We are just going to call a method called onLayerChange with no information coming through, no parameters on here. And we're going to continue to get the information about the layer hit the way we have been by just accessing the getter on camera raycaster. So the thing we're going to focus on is changing the execution flow, so that as we are sitting inside of the cursor affordance script, what we want to be doing to avoid this funny cursor bug is to get away from late update and be focusing on an onLayerChange event. So let's start off in camera raycaster and see if we can tackle this first item, which is declare a new delegate subject type. What does that mean? We talked about the subjects and the observers. Well, let's go here, just below the getters. So we're in cursor raycaster.cs. We've got our getters that get the raycast hit and the layer. And I want to sit here and say, right, how does this work? So public accessibility level. Delegate is the keyword, the new keyword we're going to use. From here on in, the rest of this line is just a standard method declaration, although it's actually a signature, really, a prototype for a method. We're not actually writing the method here. We're writing it effectively an interface. We're saying that something like layer has changed or on layer change. And I'm not going to use any parameters for the moment. That's the bit where there's no data flow. So I'm saying that the delegate is going to be called on layer change. And other methods that actually implement this may have a different name, but that's just what I'm going to be using. In fact, we stop using this on the very next line. We have to do two things. Number one, as I've just said, we declare new delegate type, and that's the onLayerChange type. Now that won't really mean anything to you until we do the next step, which is to actually instantiate a new delegate observer set. Remember all your observers down here? We need to instantiate a set of those. They need to be stored somewhere. And the way that we do that is we, again, public, because we want to be able to use this from the outside. Layer has changed because we now, or onLayerChange. This is the new type. You've got a little briefcase here. It tells us it's a delegate. Now, strangely, I'll use a lowercase, lower layer change observers, I'm going to call it for the moment, so that it's clear what it is. And this is instantiate an observer pool, if you like, or set. So this thing here is the set of observers. Okay, so fine. Probably doesn't mean much to you if you've never seen this before. So what's the next thing? Let's go and take a little look in Sublime Text and see what I've chosen to do next. Write a compatible handling function. All right, next step. Let's write a handling function, and then it'll start to come together. So we write a function. Now this function, to be a valid handler of the onLayerChange delegate, needs to conform to the same signature, i.e. void with no parameters. I don't need to give it the same name. So void some handling, some layer change handler, like that. Doesn't matter what I call it. The point is that it conforms to the same signature. All right. What's the layer change handler going to do for us? For the moment, it's just going to print, hey, I handled it. Okay. So what's going to happen right now if we run? Absolutely nothing, because nothing is calling some layer change handler. Let's just look at that, check the logs, make sure that we're comfortable. That so far we've only written some valid code because it's compiling, but we get nothing out of the logs. That's absolutely fine. That is at this stage what we would expect. So we have made the type, we have instantiated the event handler pool, the observer pool, and we've written a compatible handling function. This is the bit that ties it together. We now need to add the function, add the handling function to the set of observers. So in start, we need to do something like this. We need to say layer change observers plus equals, so whatever layer change observers started as, which is nothing, we're going to add to it, and it's a set of observers, we're going to add to it a new thing, which is, now watch this, as you start typing some layer change handler, you're actually allowed now to just use the function name. You see it's matching? You can just use the function name like that. So there's some very strange syntax going on here. What this is actually doing, by the way, this plus equals, is it's turning this function into a set of functions, effectively with an implicit cast in the front here. It's turning into a set of functions because what we have on the left is a set of functions, so we must have a set of functions on the right. So it's changing the thing on the right to a set of functions to be added to the thing on the left. I hope that makes sense. So it doesn't really matter. This is just saying, take my list of layer change observers and add to it some layer change handler. Now, the smart amongst you may say, what would happen if I just said equals? The problem there is we'd overwrite all other observers. So in our pattern here, all other observers down the bottom would get wiped out, which would be a bad thing. All right, so we're going to go plus equals. We'll talk about in the next lecture how to use the event keyword to protect all this. But for now, I just need you to understand this execution flow. I know I'm going very fast. I'm going to come back and talk about this section I've highlighted again in a minute. But for now, I just want to see if it even works, because we haven't yet made a call to the method. I think it's hard to understand all of this until it all comes together. So we need to understand how to call the delegate. So we could do that in start. And the way that you call the delegates, all of the delegates, is like this. We say layer change observers, and even though it starts with a lowercase and it looks like a variable, you call it like a method, because this thing is actually a function pointer. What it's saying is, now let's take it from the top. So this is call the delegates. Okay, so what we're doing here in start is saying, go call all of the delegates. Well, what delegates do we have? Well, it's this list here. Okay. What's in the list? Well, some layer change handlers in the list, the only thing in the list. Where is some layer change handler? Here. So all we should get is I handled it. Or maybe we even put the name of the method in as well. So let's just see if it works, and then we'll talk it through once again. No harm in repetition. Then we'll try exploring it further. Okay, so some layer change handler, I handled it. It worked. This method got called. Now, this is all in the same class, so that's very, very boring, but we're going to move stuff out into another class in a minute. What I would like you to do briefly as a micro challenge is to add another observer function here. Get your hands on this. Create a new function like some layer change handler. You can call it some layer change handler 2. Give a different log message. Add that to the list of layer change observers and make sure that both your functions get called. So have a quick go at that now. So, okay, I'm going to make another one called some layer change handler 2, like so. Now that won't be called unless I add it to the pool, like so. Some layer change handler 2. So now layer change handlers contains both some layer change handler and some layer change handler 2. I expect to get 2 printouts, which we do. Okay. How about if I was to say equals there? This is the risk of overwriting, which we'll protect in the next lecture. What I'm doing here is I'm overwriting the pool or the set of layer change observers with only this second function, a pointer to this second function. The problem with that becomes, if I play it now, we should only get 1 print, which we do because we've overwritten the pool. Okay? So we'll protect against that later. I'm just going to undo this second layer change handler. In fact, I'm going to undo, all of that. So we're back down to just a single example. So add to set of handling functions, just to comment this all up for you. All right, now the real magic comes that once we've set up this structure here in the camera raycaster CS, then what we can do is we can call the delegate from outside this class without any modification to this class whatsoever. So let's go see that in action. I think I'll see it in action by just creating a brand new class for a moment so it's empty and clear. So let's just go, I'm going to go in camera and UI. So it's a temporary class. I'm going to make a class called SomeObserver. Now I need to put that script on, well, I'm going to put it straight on the main camera for now. So it's right next to, as a component, the camera raycaster. Okay, and then I'm going to edit SomeObserver. Okay, so how do we actually how do we get a method or function that's inside SomeObserver to handle the call that is made from camera raycaster? Because that's what we want to do. We want the camera raycaster to notice when the layer is different. We'll do that in a minute. Then to call this layer change observers, one thing that handles it will be this guy here, some layer change handler, because we've added it to the pool or the list here. But we also want, without touching camera raycaster.cs, I'm going to close it. I'm going to show you that SomeObserver can come in and register itself as something that's going to handle that. So we'll get a different print statement from SomeObserver. Now, another mini challenge for you. Are you up for trying to do that yourself? I know it's a big challenge. If you are, pause the video and do it. If you're not, don't expect to do it if you've never seen delegates before. So the first thing we're going to need to do is we're going to need to get hold of a camera raycaster, because that's the thing that we that has the delegate on it. Now this is okay. We're not changing camera raycaster. The whole point of this is to prove we can do this without changing camera raycaster at all. So we go and find it equals get component. Now the reason this is going to work is because it is on the same, this script, the SomeObserver script, is on the same game object main camera as the camera raycaster. So this guy, SomeObserver, is just finding the camera raycaster. All right, so we have a reference to the camera raycaster now. Now the fun starts. We're going to write our void some handling method, or function I'll call it. I know I use those interchangeably in C# because they really serve this roughly the same purpose. And I'm going to print something like Wahoo handled from elsewhere. Something like that. Okay. So if we can get this print statement to come out, we've done really well, because what it means is cursor affordance is, where is it? Let me just find where it is. Sorry, camera raycaster, I've closed it because I don't want to let myself in it and cheat. Camera raycaster is doing the broadcast, it's calling the delegates, and I want this guy to register itself as a delegate. So how do we do that? Well, we say camera raycaster dot, now what have we got in here? Layer change observers plus equals some handling function. So we're saying this handling function wants to add itself to the pool of layer change observers. Okay, let's see what happens now. Let's just play the game. Go to the console. Yahoo handled from elsewhere and some layer change handler, I handled it. So hopefully you can see the beauty of that. The beauty of it is that this SomeObserver has been able to come in, find the raycaster, register one of its functions, this guy, as a handler, and then respond to the fact that the cursor, the camera raycaster has like broadcast this event saying, hey, something's happened, and anything else without it even knowing. I didn't change anything in the camera raycaster to make this happen. Okay, so that's pretty cool. I'm going to delete the SomeObserver class because this was just by way of example. And we're going to focus on doing that now inside the camera, inside the cursor affordance. Okay, so again, if you want to challenge, go ahead and do it. You're going to need to register a method that you're going to change late update into something like on layer change, and then you're going to register that as a handler in start. So see if you can do that, and if you can't, I'll help you. So it may take you a bit of reading around delegates to get this right if you're new to it, but good luck with it. So void on, we can call this what we like as long as it conforms to the signature that we defined in the first place in the back in the camera raycaster, which I'm still going to be disciplined and not open because I want to show that this can be done without changing the camera raycaster once it's set up. So on layer change. On layer change, now this is a huge change to the algorithm. This is no longer getting called every frame. It's not update gets called once per frame. It only gets called, when layer changes. Actually, it's not being called at all right now because we didn't quite finish our work over in the camera raycaster. We're just calling on start, so I won't put that comment in yet. And in fact, I'm not even going to call it on layer change. I'm just going to say on delegate called for now, just so we don't get confused. So, but if this delegate's called, then let's just register ourselves. Camera raycaster dot. Now we've got the list of layer change observers plus equals. Remember, don't overwrite it. And then I can just use the autocomplete actually on delegate called, and that's it. So we are registering like so, and there it is. So what I'm expecting to happen now is that, well, actually nothing, because on delegate called will get called, but it won't do anything. So let's make it do something. And of course the cursor affordances temporarily won't print. So let's just say cursor affordances or delegate reporting for duty, exclamation, jury, whatever. Okay. So if this works, we've just registered ourselves. From again, I've had Camera Raycaster closed all this time. I've been able to register myself, and I'm hoping that on start we'll get cursor affordance delegate reporting for duty. So we'll have two logs again. One from inside cursor affordance, where I just showed you right in context. And we've got a script missing. Let's just fix that. That's just because I removed this new script that I created, that temporary script. Let me just remove that because we don't want a face full of errors. Great, okay. Cursor affordance delegate reporting for duty. Awesome, that has worked. So we are nearly there now. We have nearly got, well, we have all the tools that we need to be able to just get rid of that, to be able to just back over in the Camera Raycaster, set up a tiny little if statement that says, well, actually only call the delegates when the layer changes. So that's what I want you to do as a challenge. So in essence, switch the cursor to the delegates model. Stop setting your cursor every frame. We've kind of done that, but it's not being set at all now. Implement the observer pattern in your code. I've showed you how to do that, and share your feelings and understanding with the community. Ultimately, this boils down to, as I say, back in the Camera Raycaster, just only calling the delegates when the layer changes. So have a go at that, and I'll see you in a second. Okay, welcome back. So look, if this is the first time you've ever seen delegates, don't beat yourself up. It's difficult. You're going to need to scratch your head and look at it a lot. Just absorb this, and we'll use them more in the project as time goes on, and you'll learn them through absorption. Don't stop taking the course now and just wait until you fully understand delegates, please, because I think that trying to do that the first time you meet them without some real-time feedback from somebody is going to be really hard. If you really want to understand it, then go and use our forum and our chat server and get enough feedback to understand it before you carry on if you wish, or just allow yourself to carry on and learn it through absorption. Okay, so what I'm going to need to do is I'm going to need to go back now and open the Camera Raycaster. I'm going to rip out this some layer change handler here. I don't need that anymore. I'm going to rip out the registration of that as well. I'm no longer going to call layer change observers on start, so I'm going to get rid of that. Well, or at least I'll be ready to get rid of that. I'm going to copy that line of code down or move it down in a moment. But what we need to do is this. We look through all the layers in update of Camera Raycaster CS. We then look through the layer priorities. We go and see if we get it. We go and raycast and we see if we get a hit. And if the hit has a value, we say raycast hit equals hit.value. So under that, it's this bit that we want to say, actually, only if layer hit does not equal the layer, do we then set layer hit to the layer. So this is like a toggle. This is saying only if the layer hit is different, if layer is different or has changed, then, well, we better set layer hit to layer so that next frame it doesn't look like it's changed, right? Now, we can do that before or after, but crucially now is where we do the delegate call. It's now we say only when the layer changes do we call layer change observers, call all of the observers. All right, so this is the small change I've made in here. I've said if the layer has changed, call the delegates. All of the delegates, we don't know how many components, as I showed you by setting up that new component, will have written delegate methods or functions, and we don't even know if they have multiple functions, and we don't care. We're just saying if the layer changes, broadcast that fact. Okay, let's see how this works. Okay, we have walk, we have enemy. Ah, that's cool. And it's working. Now that is really cool. And now we still have not moving to enemy. We're going to deal with that in the next section, but we're not going to have any cursor drift anymore. Let's convince ourselves of that. How often is, for example, the handling method being called? So let's just quickly take a look at that. So in cursor affordance, when on delegate called, let's just say print layer or cursor over new layer. That's all we need to say. So this is on the handling method, one of the handling methods inside the cursor affordance. Let's go and see when that gets called. Cursor over new layer, I'll turn collapse off. And then if I hover over the enemy, cursor over new layer, and back over the ground, cursor over new layer. Okay? So it's only getting called, and hence the cursor is only being changed when there's a new layer. Only when there's a new layer. Much, much, much better architecture. Now, we're still getting our data about what that layer is by saying camera raycaster.layer hit. So this diagram should make a bit more sense now. In this architecture, camera raycaster is only calling the delegates when the layer changes down this solid line, the execution line, into cursor affordance. And that's when the onLayer change method gets called. Here it is. Well, I've actually called it onDelegateCalled, but now I'm actually going to rename that to onLayerChanged. I only called it onDelegateCalled because in the beginning it wasn't about change of layer, it was just being called from start, just as a test. So it's calling onLayerChanged, but the way onLayerChanged is getting its data about the layer from camera raycaster is camera raycaster.layer hit using the getter. Now we could, with delegates, pass this through as a parameter, and because that's a useful facility, I'll probably show you that in the next video. But for now, the real problem we have is that we can accidentally say equals here, and we can overwrite any one component, can accidentally overwrite the entire list of layer change observers. Bad. That's bad. We need to protect against that, and we'll see how in the next video.